Next up, we'll hear from John Vandermay, who is the CTO of Seequent, and we'll do Gaia 3D at a later time. So let's welcome John on stage. And today, John's going to be talking about Seequent's new platform, Evo, which integrates with Cesium and also makes underground data available to developers through open APIs. So let's welcome John onto the stage and keep our fingers crossed.
Good morning, everybody. How are you? Just give me one sec here. I'll get the display extended. Don't you love technology? Okay. Dun dun dun. Good old Mac to the rescue, right? So hey everybody, my name's John Vandermay. I'm CTO at Seequent. I've been with the company for 2.5 years, and over that time we've been very focused on building out our next generation geoscience platform, with which we've extensively used and take advantage of Cesium, Cesium.js, and 3D tiles in the platform. But I want to give you a bit of a background on our company and who we are. So Seequent is part of Bentley Systems. We were acquired by Bentley Systems about 4 years ago. So Patrick and I have a lot of frequent interactions in terms of leveraging their technology and their capabilities into our product and into our portfolio. We represent the subsurface, so a lot of what you've seen so far, what we saw this morning in terms of what we've done within iTwin and iTwin Capture is above ground, and Seequent is the subsurface company within Bentley. Seequent still stands as its own brand within Bentley. Within the industry as well, we are known as Seequent. We are not that well known as Bentley, but we are representative of the subsurface. Now, as a company, oh sorry, one slide ahead of myself there, sorry. So we are the world's leading provider of software within the industry. We have a dominant share across a number of different verticals in the subsurface. We probably have 70% plus market share across all the different segments within the subsurface. Our software is used across a number of different segments and actively used across all different types of industries. In terms of our company, we were founded a couple of decades ago in 2003, and we've been expanding a lot ever since. We have over 750 team members within our company. We have customers in over 145 countries. We have office locations in over 45 countries around the world, and we're very well represented across different industries and different segments. We have over 26 products within our product portfolio, and in fact, we're playing across a number of different segments. So we're very well known in the context of mining. We're very well known in the context of civil engineering as well. So obviously, when you want to build a bridge or a tunnel, you want to understand what's beneath the surface of the earth. Without that understanding and comprehension, you introduce all kinds of risk into your projects. And so understanding that subsurface is absolutely critical. Just over the last couple of years, there's a couple of products we've really introduced, and one of the challenges we see in the industry is the lack of geoscientists entering into the industry. And so a couple of years ago, we started working on a project called Visible Geology, which is a tool that you've seen here that we launched last year in 2024, which really helps inspiring budding digital newbies, if you will, into the industry and help them understand geosciences and understand the industry and what's going on. So we've gone from, with that new product, we released it a year ago, and we've gone from 0 users on that platform to over 90,000 users around the world that are using our products today. It's free software. It's available at visiblegeology.com. And we're seeing a lot of engagement with academia where people are using this technology and using those products within the platform. The other innovation that I want to talk about today is Seequent Evo. Now that's something that we've had in the works for a while, but it is an open platform for geospatial subsurface data and representation thereof. That's something I'm really excited about, where I've been spending a lot of time. By background, I'm a data guy. I built a lot of technology over the years. I'm a very data-centric in terms of my thinking and how I think about industries and data, and that's where we've been spending a lot of our time. So Seequent Evo is a unified platform for your data and compute. It's an open platform that we've launched with the release. The actual release of and availability of Evo is next week, Tuesday. We've been in limited availability with the product for well over a year, and really excited about what we've done and what we've been able to pull together here. You know, our focus with Seequent Evo has been on simplicity and ease of use and ease of data ingress and data egress. That's been an absolute priority of ours. And opening up the system, opening up the data, and the ease by which people can get data in and out has been pivotal. There's just a huge mess of different technologies in the industry. There's bespoke siloed systems on the one end, and there's nothing over here on the open end until now. A lot of the technologies and vendors that you see over here are locking people, technologies, and products into siloed, walled gardens. They're locked in, and the industry we see is going that way. Seequent over here has been focusing on open systems, schemas, data, and we're going that way. They're going that way, we're going completely the opposite way in terms of how we think about things. So as a technology and an architecture within the platform, this provides some context of what Seequent Evo is. It's a unified system, as I mentioned, with the data and the compute, and it really is about connecting people and their data together with the compute to allow people to collaborate and work with the data in a unified, seamless, easy-to-use way. It really enables developers to easily access and work with that data and the compute. Now, a couple of examples within this visual here, you'll see two applications that we have built on top of Seequent Evo. One of them is called BlockSync, and one of them is called Driver. And there are two applications that we've built on top of our APIs that allow you to do different things in the context of mining, which is one of the segments that we're in, to allow people to be able to work with that data. Now you'll see that around Seequent Evo though, all Seequent applications in the top left there, you can see that Seequent products are all integrated with Seequent Evo. So we are across geophysics, geostatistics, geochemical, geological modeling, you name it, we're across all of it in terms of understanding the subsurface. So we have the capabilities built within the system that allows for that. The one thing I really want to pause on though and talk about with you for a minute is the open APIs. One thing that's really important though before I hop into that is to talk a little bit about our use of Cesium within the platform. Now Seequent Evo heavily uses Cesium.js for representing the data on the surface of the planet. As you can imagine, with all this geoscience data, because we have the world's largest mining companies, some of the world's largest engineering companies as customers of ours, they're dealing with huge data sets, huge numbers of projects, huge sets of data that they're working with within the platform. And being able to know where they are, to be able to geospatially search on those, to be able to find those is critical. So that's where Cesium.js comes into play, where we actually visually represent. I have a video coming up in a minute where I show that, where you can see how the product is able to render that data and show it to you so you can see it. The other place where we take advantage of Cesium technology is with 3D tiles. Now, geoscience objects, it's, understanding the subsurface, working with the subsurface is very different than working with the seen world in terms of what you can see. Everything that you've seen here today thus far pretty much deals with what you can see. It's in a seen world, it's in what's around us today, the building, the light, the post, the street sign. In subsurface, you're dealing with structures that already exist that you can't see. And rendering that, modeling that, knowing how to extract that resource is absolutely critical and a very difficult problem to solve. Because you're dealing with very sparse data, because you have, like in the context of mining, for example, you have a drill hole over here, and you're dealing with 100 kilometer by 100 kilometers, so 1,000 square kilometers data set, right? And you have drill holes in the ground going kilometers down into the surface of the earth, and you have a data set you have a data point over here, over here, over here, and they're like 10, 20, 30 meters apart. And so you'd think that if you have a silver grade of X here, a silver grade of X here, and that across a series of drill holes, that it'd be like a straight line in terms of representing that structure. But the reality is in subsurface, There's all kinds of tectonic activities, faults, folds in the data, and the actual data doesn't just go like that. It goes like this, right? It's all wavy like that. So, that is important to understand because there's all kinds of math, machine learning, predictive capabilities, statistical modeling that goes into understanding what's beneath the surface of the Earth. And so being able to represent that effectively requires ridiculous amounts of data that's generated by these models. And so visually representing that and showing that requires tremendous throughput and capacity to be able to represent that data. And 3D tiles, in the context of Seequent Evo, has been absolutely transformational. Now, we use 3D tiles in context with 3JS for representation. So the visualization of the data is through 3JS. So you heard Patrick talking about that this morning, how we're taking advantage of the partnership between 3D tiles and 3JS has been very enabling. And we're seeing that here very truly and truthfully within Seequent Evo as well, where the representation and visualization of this data has been so foundational. Now, I want to talk about the APIs for a second. And you heard me mention that one earlier. And you've heard me talk about Seequent Evo being open. And it is truly open. We haven't just opened the APIs, and here's our reference documentation. We've actually opened up the schemas, the way data is stored, the way the schemas are represented. We have active engagement with the community. We have RFCs in play where we're actually looking for comments and feedback as we extend the schemas and the domain model, the ontology of the subsurface within Seequent Evo. And having that openness is transformational to the industry. Seequent has decades of experience in the subsurface across all the different geoscience disciplines. So understanding that data, understanding those structures in that context, and having an ontology over that that's open, that allows for ease of data ingress and egress is critical. And you heard Sean from Google this morning, Waltman, talking about AI. And true, valid, quality data is table stakes, is a base, bare necessity for driving next generation AI capabilities. And Seequent is bringing decades of experience to be able to support that next generation step in terms of the AI and understanding the subsurface and opening that capability up in a way that anybody can take advantage of it. We're looking to really transform the industry by opening it up to you, making it available to you to be able to understand the subsurface. And our goal is really enabling subsurface transformation in industry at scale. So here's a few examples of some of the open source reference that we have. We have our developer documentation that's available through our developer portal, developer.sequent.com. And then we also have our reference implementation. So you can see that we've actually open sourced the SDK, so it's on GitHub/Seequent Evo, where you can see our actual schemas, our Python SDK that makes it very easy for scripting, getting data in and out of the platform. And we also have our data converters. So we have a number of converters that we have released, that we have made available, and we encourage active engagement from the community. I'd love to get your feedback on it. If you spend time with this and you have some feedback for us in terms of what we've done and what we've built, I welcome that feedback. It's john.vandermay@sequent.com is how you can reach out to me. And I welcome the conversation, discussion in terms of what you see relative to the problems you're trying to solve in terms of subsurface. Thus far, we've seen some fantastic engagement from our customers. It's been fascinating to see where we've been talking with some of the largest engineering companies and mining companies, and it's wonderful to see the level of engagement and response that we're having to this, because the whole narrative of their data not being locked into a walled garden, that the customer's data is their data, it's not our data, it's their data, and the simplicity and ease by which they can get data in and out is just so powerful and so transformational. And the engagement that we're seeing from CTOs and CIOs in these companies is really, really exciting for us. So here I'm going to start a video where you can see the actual implementation on the UI aspects. This is the user interface to Seequent Evo. And you can see here how we're taking advantage of Cesium.js. And I only have a few geoscience objects that are being referenced here, but we have customers that have hundreds of thousands or millions of geoscience objects that are referenced on the planet that you can see within the platform. And you'll see that we've created an experience today where from within Cesium.js, you can zoom into a particular geoscience object, and from within that, you can create the 3D view of that object within the platform within Seequent Evo. Now, that visualization and that experience will be transformed over time, where we'll actually start taking the surface layers from within Cesium through the different providers and being able to represent those within the platform. So here in this view, for example, you actually see a surface mesh within the platform that was uploaded into Evo, but you'll be able to select Cesium within the platform itself to be able to layer that into the scene. So here you see a set of drill holes that are being represented in the context of that surface mesh. The thing I'd like you to keep in mind here is that this data, and Evo does not care where the data came from. This data can come from Seequent products, it can come from our customer systems, it can come from our partners' systems, and in some cases today, we're actually seeing competitors' data being loaded into Seequent Evo and operationalized through the API and visualized within the platform because the other platforms can't do it, which is fascinating to see. So you see the visualization capabilities, and keep in mind it's all through 3D tiles, and I'm using Three.js. Because we're dealing with massive amounts of data. You can see the tiling of these objects coming into the platform, and the intersection between 2D objects. So you see here a geophysical grid, which is about 50 meters down below the surface of the Earth, overlaid with your 3D geological model. So you can actually get a sense of what that subsurface is and what lies beneath our surface of our feet, because we just don't know. So very, very profound capabilities within the view. And so as I mentioned, we're dealing with absolutely massive data sets. Here we see a view of a few thousand drill holes, and we're actually generating a model of the anisotropy against through those drill holes. We have a machine learning model that's behind this that we've trained over years that is actually showing the veining and faulting in the structure to be able to generate more accurate structures of what lies beneath their feet. And keep in mind, these are all things that you can't see. This is all interpreted, this is all predicted in terms of the capability and the faults coming into the platform in that context. So very, very transformational capabilities in regards to the openness and being able to bring the data in whatever format into Seequent Evo, which is really, really exciting. And then finally, in the last bit of the video coming up here, you'll see a block model, which is basically an oct tree of the subsurface. And that's what mining companies will use to assess the context and extent of their deposit. Now, people always say to me, oh, well, that just looks like Minecraft. Well, no coincidence, a lot of the concepts that you see in Minecraft in terms of working with blocks come out of mining. But this is what you see in the context of mining today, how mining companies optimize and work with their subsurface deposits and how they plan for the extraction of the resource and optimize the efficiency within the context of their mining operations and when they should extract which block in the block model to drive efficiency into their operations. For a bit of context, maybe a bit of background in terms of mining, in a mine site, the mill is set, which produces the actual resource, is set to work with a certain grade of deposit. So if you put in a grade or bring in a block from the block model that you've taken out of the mine that is too high grade, you have waste. And if you have a grade that's too low that goes into the mill, you also have waste. So, because you would think, well, I'll just extract the highest value, the highest grade deposit first, or block from the block model first. You're not going to do that. You want to balance the correct grade going into the mill. So optimizing that against your block model is key. So we're seeing a lot of customers that are taking advantage of the capabilities within Evo to optimize through the block model. Sorry, this is just on a loop, so this is just playing over again. So with that, I wanted to wrap and thank everybody for joining me here today. I want to thank the Cesium team, with the contributions they brought to the table and the level of engagement that we've seen. We launched Seequent Evo at a conference in Toronto. The Prospectors and Mining Conference was attended by about 35,000 people. And our booth was lined up 3 deep. We couldn't pack any more in because they were so amazed with the capability and the openness of what we've built. And the level of engagement, participation, contribution from the Cesium team has been wonderful, and I thank the team for their level of contribution and helping us along the way as we've been driving towards open source. It's been absolutely transformational. So very grateful to the team and the contributions. And with that, thank you very much. I'll take any, do we have time for questions? We don't? Okay. I'll hang out back here if you have any questions. Happy to chat. Thank you.
Great.